Aloha class. In this video, we're going to talk about the deck interface. Think of a deck interface as kind of like a deck of cards. You can work from the top or the bottom, depending on how crooked you are. Uh, Poker joke there. Anyhow, with the deck interface, this is another one that's kind of like this, the stack. It's part of the Java Collections framework. So it's an interface that's defined therein, and you can implement them using the linked list. So if we wanted to go ahead and create one, we could instantiate it using the code that you see here. Deck of T, where T is the type that we want, like integer, string, double. Then we say equals new linked list of, and then the type again. So we go ahead and we set it up that way. And then we can go in there. Well, in order to do all this, we first have to import both of our linked list and our deck. So you'll import those two, and that'll allow you to do it. So if you wanted to implement a stack using a deck, you can, because remember, a deck is going to be a little bit more elaborate than the stack. Stacks, if you remember, a stack is like a stack of dishes. You put one on, and that's the bottom. You put another one on, and that's one on top. But the first one that you entered is now the last one that'll be coming out. So you essentially remove from the top, and you also add from the top. So with a deck, you can implement that same structure by doing add first and remove first. So when we say first, we really mean the top of it. So if we add first, we're going to be adding to the top. And if we do a remove first, we're going to remove from the first. So if we do add first, then add first, then add first, then we do remove first, we've essentially got a stack. So the stack is not exactly what we want here. We want the stack functionality, plus we want to be able to serve from the bottom, and we want to be able to add and remove from the bottom of this as well. So the way that we do that is through a number of the methods that are available to us. First, we're going to show off the stack functionality here. We'll look at this participation activity. And it says addFirst method adds an element at the head, and removeFirst method returns and removes the element at the head. So we look in here, you'll see that we're setting up a string-based linked list of deck, and then we're printing out depart Tokyo here. So then we're gonna go ahead and put Osaka in next, and then Nara after that. So after we've done that, essentially we've put in these different ones. We had Tokyo at first, then Osaka and Nara. So then when we run again, we're going to go and we're going to start removing. So we remove first, the return trip is going to be Nara, and then the second one's going to be Osaka, and then the third one is going to be Tokyo. So we're using both addFirst to do that and removeFirst. So we've just created a stack essentially from a deck, from a linked list. So here, use decks addFirst and removeFirst to go ahead and do this. Let me remove the answers there real quick and go down here. What is the value of the element at the head of the deck? So filter, download, process. So the first one that we put, or the first one that we add in here is going to be on the bottom. Then from that, then process. So we've got process is going to be that. And then what is the value of the element at the tail of the deck? So the tail of the deck is going to be opposite ends. So that's going to be filter. And we've got to complete the statement to add the value draw. Actually, I'll let you go ahead and finish these up. Yeah, they're all based on the practice we just did before with addFirst and removeFirst. Then the common deck methods, there's a bunch of those here because, again, we have all the functionality that we had in Stack. And remember, Stack had some neat stuff like polling and element and stuff like that. So we've got all that in here, but we've also got it for the last element as well as the first. So in here we have addFirst, and that's going to add the new element that we've passed in. It's going to add to the head of the deck, and the deck size is then going to increase by 1. We can also do an addLast, and that's going to add the new element to the tail of the deck. And again, the deck size is increased by 1. We can do a removeFirst, which is going to remove it from the head of the deck. And this one's going to throw the exception. removeLast is going to do the same thing. It's going to remove, or not the same thing, but it's going to remove from the bottom, and it's going to throw an exception if it's empty. So then we've got the pollFirst. So pollFirst is going to remove and return the element at the head if the deck is not empty, but it's going to return a null instead of throwing the exception if it's not. So then we've got pollLast, and that's going to remove and return the element at the tail of the deck if the deck is not empty, and it's going to return a null if it is empty. So you're not going to have to worry about handling the exception. So in polling, you don't have to worry about handling the exception. Then we've got getFirst, and getFirst is going to return but not remove the element at the head of the deck, and it's going to throw an exception if the deck is empty. And then getLast is going to return but not remove the element at the tail of the deck, but it's going to throw an exception if the deck is empty. And then we have the peek of the gets, which is kind of like the same thing for like the polling. It's going to try to return it but not remove it. And then well, it's going to return but not remove, and then the element at the head of the deck if the deck is not empty, but it's going to return a null if it's empty. So with peekFirst, it's going to do the same thing that getFirst tried to do, but instead of throwing that exception if the deck is empty, it's just going to return a null. And then peekLast, same thing for the last element. It's going to return it but not remove it. And then if the element at the tail of the deck is not empty, if it is empty, it's just going to return a null. So these are kind of the peeks, and the polls are kind of like safe ways of doing it where you're not throwing exceptions. So then the programmer should select the deck implementation. This is just like stack. It should select the deck implementation that is appropriate for the intended task. You can also do array decks, linked blocking decks, and concurrent linked decks. And then we're going to take a look at our code here. I'll do the first one, and I will take a look at this. So we go through, we set up a deck of strings, and we're going to add laundry, we're going to add homework, we're going to add groceries. So we've added all these things. So the thing on the top right now is groceries. So we're going to remove first. So removeFirst is going to tell us groceries. And because it's a print line, there'll be an enter there. So we did that. Oh, wait, but removing first, we actually didn't display that. We returned it, but we didn't display it. So we've got groceries. So now we're going to remove first again, and that's going to give us homework, just like I do. I'm going to give you homework. Okay, so we've got homework there. So that should be it. And that's absolutely wrong. So, oh, yeah. So once again, I did not read the instructions very well. I didn't put the 1 point and then put that in there. So do pay attention when you're reading this, unlike myself, and yeah, do this properly. So laundry, gardening, homework. So we're going to remove first, and that's going to remove the homework. And then we're going to have gardening left. So we need to put in the 1 point space. Don't forget the space because it doesn't like that. We're going to put in gardening. Then we're going to remember to hit, or no, wait, we're doing a remove first. Yeah, so we remove the first, and then we're doing a remove first. So we're removing the gardening. So that's that. Now we check it, and that's correct. So be careful in your reading. Don't do what I do, which is read too fast and forget what they're asking for. So then you'll go and keep on doing this. And then for our challenge activity, I'll let you do this, but again, it's just like before when we had to add our variable declarations and our code. Look at it, and it's asking us to declare variable seat numbers as a deck of type integer. So again, what you'll do is I just want you to go up here. You can be lazy about it. I guess I'll start this thing for you, but I won't actually finish it. I'll just go in here, but we're going to put in our deck here. It's a declare variable seat numbers as a deck of type integer. So we go in here, and it's going to be a deck of type integer. So that should get you that far. Then assign seat numbers with a linked list of type integer. So yeah, so you'll want to go ahead and add those in. Read 3 integers from input and add each integer to the head of, yeah. So you're going to be doing the same thing we did before. You're going to set up a loop that goes over 3 times and reads from read in. This time it's integer, so you're going to do next int for that. So go ahead and read those 3 things in, add them in, but notice where it says to add them, add it at the head of seat numbers. So go go ahead and do that on your own, and there's 4 parts of that. And again, this is a quick section on decks, but if you have any questions, feel free to reach out. Again, decks, the thing to remember is you can add at the top, remove from the top, or you can do it from the bottom. And you have all kinds of specialized functions in here to remember, ones that will throw exceptions and ones that won't, depending on whether or not your deck is empty. So, yeah, so go ahead, get familiar with these, and I will see you in the next lesson. Have a great day. Aloha.